So, we completed till the general law, then the triangle law, then the law of polygon, then the parallelogram law, and so on, so on. All right. So, you were given this math. Did you do this one?
Uh, um, I am able to do that.
Okay. So, what you have to do is see resultant displacement. If the displacement of a particle is 4 kilometer and 10 kilometer respectively along the north and the east. So, along the north, you will have 4 kilometers, and along the east you will have 10 kilometers, right? So obviously you understand that the displacement would somewhat occur in this direction. Okay, so now what is the angle between these two? 90 degrees, right? Hello, I cannot hear you.
Oh, you can't?
All right.
Can
Yes.
you hear me?
Yes, now I
Okay.
can hear you. So angle is 90 degree, right? So that means the resultant factor will be equal to 4 squared plus 10 squared plus 2 times 4 times 10 times cosine 90, which is obviously 0. All right. So that will be equal to square root of 4 squared plus 10 squared, which is square root of
136.
116, right? So that is
Yes.
our answer. Okay. Now tell me what will be the angle or the direction of the resultant. Okay, this is your job. Let me know. So, okay, finish it.
Where's my calculator? Oh, okay. Would it be 10 10 theta is equal to
And theta
q
equals
sine
to
q sine alpha over p plus q sine cosine alpha cos alpha.
and alpha. You are just like saying the what can I say formula or the equation.
Yeah,
What is the answer?
is that the right answer? Um,
Yes, this is the right one. We did it yesterday. Okay, you can't be confused. Okay, you have to identify what is theta, right? With
yes.
which vector are you considering the theta? That is really important. Okay, so don't make a mistake there.
Which um 21.8.
21.8 degrees, right? Theta equals to
Yes.
21.8 degrees. With respect to which one?
Um, 10 kilometers.
With respect to 10 kilometer. Okay, so this much is 21.8 degrees. Okay, let me
The
check.
horizontal
Let us
plane.
check. Okay. Okay, so with respect to 4 kilometer, they have taken that is 68.2 degrees, and you have taken with respect to the 10 kilometer, which is 21.8 degrees. So your answer is correct. There is no problem in that. Okay. All right.
Hmm.
Now, obviously, I've already mentioned what is the case if in case of like alpha equals to 0 degree, 90 degree, or 180 degree. Okay. So I'm not getting into those now. Now, all right. So now comes the part where we will need to use the sense of component. Okay. So let me take a screenshot of this. 1 second. All right, just a second. So this one, all right. So we're going to solve this. Okay. So let us solve this. So what are they saying? That the velocity of a sailing boat in favor of the current in a river is 18 kilometers per hour. And against the current, it is 6 kilometers per hour. In which direction the boat is to be driven in order to reach the other side of the river? And what will be the velocity of the boat? Okay, very good. So let us consider this is our river. Okay. Let's see if this is like water. Okay. All right. Now what they're saying is say let velocity of or the speed or velocity, whatever you want to call it, velocity of boat equals to u and velocity of current equals to v. All right. Now, say for instance, let us consider that the current is flowing in this direction. Okay. Current is flowing in this direction. All right. Okay. And the boat starts from this point and it exactly wants to reach the opposite side. Okay. It exactly wants to reach the opposite side. In order to reach the other side of the river, they're saying other side of the river, that means exactly the opposite point. Understand up until now?
Yes.
Okay. So now, this in this direction, we have v kilometers per hour. Okay. And we don't know what will be the direction. Say, let us consider this will be some sort of direction. Why am I taking in this direction? Because if I start going to the left, then the tide will take me to the right, and eventually the resultant will end up here. Understand the concept behind this?
Yes.
Okay, so it's in physics. It's just not only mathematics. You have to be like, what can I say, conceptually clear, or you have to visualize some things, right? If you go to the left and the tide takes pulls you in this direction, then you end up somewhat in this direction. Okay, so say this is u kilometers per hour. Okay, and the angle between these two is alpha. Okay, and obviously the resultant is r. Okay, let me know when you are done with drawing this picture. Whenever you are doing any math of physics, uh, like in case of especially the Newtonian mechanics, which involve like velocity or force, something like that, it's really necessary that you draw the picture of the whole scenario. Okay, all right, are you done?
Yes.
Okay, so now see what they have said in favor of the current. That means if I like row the boat in this direction, then the velocity is 18 kilometers per hour. So in that case, won't the velocity be u plus v? Because both the vectors are going in the same direction. That means the resultant will be p plus q. Remember, in case of alpha equals to
Yes.
0 degree, right? Okay, so that thing. So what will be u plus v equal to?
Um, 24 kilometers per hour.
Why 24? Read the question.
Um,
The velocity of a sailing boat in favor of the current in a river is 18 kilometers per hour.
18 plus -6 would be 12 kilometers per hour.
Why are they saying 18 plus negative? Okay, read the question. The velocity of a sailing boat. Okay, so the boat is sailing, right? Then it
Yes.
has some velocity of it, which is u, and in favor of it, it also has a velocity of v. It also has a velocity of v, which is like the velocity of current or something in favor of it. That means the total velocity in favor of the sailing boat or the resultant velocity is u plus v, right?
Yes.
So that means u plus v equals to 18 because the in favor of the current it is 18 kilometers per hour. Understand my point?
Yes.
So tell
Oh,
me, are you getting me?
yes.
Okay, so now tell me, if I say okay, say if the boat goes in this direction, okay, if the boat goes in this direction, which is against the current, then its velocity will be, tell me, if alpha
6.
is equals to 180 degree, that means u minus v, right?
Yes.
Okay. So it will equal to
6.
6. Okay.
Negative
Now
6.
let us
Yeah.
solve these two equations to get the velocity of the boat and velocity of the current. Now you could have asked me a question, why u minus v and not why not v minus v? It is because we are considering that the velocity of the boat is greater than the velocity of the current. Okay. Otherwise, it will be, uh, I mean, it's possible, but that is of like very higher level of mechanics, which is out of our syllabus. So we are considering that if the velocity of the boat is greater than the velocity of the current, then only will it be able to reach the other side of the river. Okay. All right. I'm not saying it is not possible if the velocity of the current is greater than the velocity of the boat, but that is not like out of our syllabus. Okay. All right. So anyway, understand my point? Why u is greater than v?
Yes.
Okay. So now if we solve, this is a very important math, by the way. Even in your syllabus, it should be a very important math. All right. So that means twice u will be equal to, if I add them up, so 2u will be equal to 24. That means u equals to 24 upon 2, which is equals to 12. Right? Is that correct?
Yes.
That's simple like equation, nothing else. All right. Now again, if I like subtract these two equations, I will get 2v equals to 12. Please let me know if you don't understand like what is like what am I meaning by addition or subtraction, something like that. You understand, right?
Yes.
Okay, 2v equals to 12. That means v equals to 12 upon 2 equals to 6 kilometers per hour. Is it clear up until now? Tell me.
Yes.
Okay, good. So that means we have got the
Yes.
value for the boat's velocity, which is 12 kilometers per hour. And we have got the value for the current's velocity, which is 6 kilometers per hour. Now, I'm going to tell you a law for the component. So what is the law for the component? It is how much, I mean, say there are like 8 or 10 vectors. Okay, 8 or 10 vectors. If you take the horizontal component of all of them, it will equal to the resultant horizontal component. Okay, so what did I say? Say infinite. I'm just saying it for like your understanding. Okay, don't write it like this in the exam. Okay. Okay. Can you hear me? Am I audible? It's
Yes.
saying my. Okay. All right. Let me know if you don't like, hear me. All right. So infinite number of vectors horizontal component obviously summation of them components summation equals to resultant vectors horizontal component. Okay, horizontal component. Now in the same way you could say infinite number of, tell me, what do you think, what am I going to write? What is the what summation am I going to take now?
Of vertical components.
Right, exactly. Vertical components equals to resultant vectors vertical component. Okay, vertical. All right. Now, how did this like equation or like the formula came from? It's part of our mathematics syllabus. When you will study statics, there is a particular chapter in statics. We will discuss that in detail. Okay. For the time being, I'm not going there. Okay. Anyway, so now From the first part, what do we get? Tell me, what is the horizontal component of V? Tell me. Let's see how much you remember. What is the horizontal component of V?
Uh,
How do you get a horizontal component?
addition. Oh wait, no, 3 cos alpha.
3 cosine alpha. Why 3 cosine alpha? I'm saying,
Sorry,
asking for the
not 3
horizontal
cos alpha.
component of
The
V. Okay.
um vertical
Did
x
you
cosine alpha
revise the class note of the previous day?
v
What did I say? I
6
said
cosine alpha
that,
6 cos.
okay, so for V, okay, okay. So for V, what did I say for like calculating the horizontal components or vertical components? What you have to do? What you have to do is see, this is like consider the angle between x-axis and V. Okay, that is what I said, right? So what is the angle between x-axis and V? They fall in the same plane. That means what will be the angle?
0.
0 degree, right? So yes,
Yes.
cosine 0 and
Yes.
then multiply it with V. Okay, that is what I said. Now again, another vector is U. What will be the horizontal component for U? Tell me.
V sine
I said horizontal component
v
of U.
sine um
Do we involve sign in case of horizontal components?
no
What do we involve?
um u cosine alpha.
U cosine alpha, right? It will be U cosine alpha. All right. So these are the
Mm.
vectors which were working on the board. Okay, these are the vectors which were working on the board. And it equals to what will be the resultant vector? It is R. Okay. Then R's horizontal component. Now you will tell me what is the R's horizontal component? What is the angle between R vector and x-axis?
90 degrees.
90 degrees. Now tell me what will be the horizontal component of R?
uh, Cosine 90.
Good. Cosine 90. Okay, very good. Okay, so let's simplify this equation. So this will be V plus U cosine alpha equals to 0. Now we will get, let us just plug in the values. So we have 6 plus 12 cosine alpha equals to 0. All right. So now let's subtract 6 from both the sides. Then it will become 12 cosine alpha equals to minus 6. Then cosine alpha equals to minus 6 upon 12. Then cosine alpha equals to minus half, right?
Yes.
So what is alpha? Alpha will be equal to 120 degrees. Okay. Alpha will be equal to 120 degrees. Tell me if you don't understand anything, tell me. Please let me know.
Yes. Oh, I
Okay.
understand. I'm just writing it down.
I think, let me switch to mobile data. I think. Okay. Okay, take notes of this. Let me just switch to mobile data. All right. So understand. Okay. So we have taken the horizontal components. Okay. And as I said, no matter how many numbers of vectors work on a particular object, we will take the summation of all those vectors horizontal components, and it will equal to the resultant vector horizontal component. And again, no matter how many vectors work on a particular object, we will take the vertical component of all those objects and it will equal to the resultant vector's vertical component. Okay? So are we clear with this?
Yes.
Okay. And then we just solve the equation to get the alpha equals to 120 degree. Now, in the same way, tell me, what will be the equation for using the vertical components? Okay, we have two vectors working on the object. One is u, one is v, and there is another resultant vector r. Tell me what should be the equation. You have to be able to solve this by yourself. Okay, otherwise it will be difficult. Tell me.
Yes.
Go ahead. Start with v.
Just 1 second.
Okay, all right.
Hi, I'm back. Where am I?
Okay, so
What is
I
going
am
on?
asking that what is the equation for using the vertical components. Okay, so there are two vectors, one u and another v, working on this particular object. Okay, so I mean, let me know what are the vertical components. Okay, so what is the vertical component for v?
Um, V sine 90
V say 90. Why 90?
because it from the vertical component to the
I,
wait, you're
I,
not
I
going
did I
backwards.
mention that you have
Two
to
set
calculate the angle with vertical? I don't think so. I mentioned that you have to calculate the angle with x-axis, right? And in the anti-clockwise direction. Okay. I still remember from the previous day. I mentioned that you have to calculate the angle with respect to the x-axis and in the anti-clockwise direction. Even I mentioned
so would
one
that
thing that say if this is say 30 degrees, you won't take it. You would rather take 30 degrees. Okay.
so it would be
Remember now.
270 degrees.
Okay.
So
So now tell
would
me,
it be two so would it be 270 degrees?
why is it 270 degrees? Say if I draw say for instance this is x-axis, right? This is x, oh x prime. This is y, oh y prime. Alright. So now tell me, if the v is in this plane, what is the angle between the x-axis and v?
0.
0 degree, right? So what should be the vertical
Yes.
component for v then?
90.
How come there's a 90?
But
What did I say? What is the angle between x-axis and v?
0.
0 degree. So what is the vertical component then? How do you get the vertical component?
The opposite.
I don't think you have revised at all the yesterday's class. I say clearly that whenever you are working with vertical components, there should be, you have to multiply the vector with the sign component, right? That is sine, then the angle between x-axis and the that particular vector, which is 0 degree, right? And then multiply it with the vector. Okay. I don't think you are recalling anything at all. Okay. Tell me what will be it for the u? What is the vertical component for u?
U sine alpha.
U sine alpha. Good. Now, what in the right side? What is the resultant vector's vertical component?
Um, V plus U sine alpha.
V plus U sine alpha. I'm not saying
Yes.
what it equals to. I'm saying what is in
Oh,
the right side.
90.
Resultant vector's via vertical component. What is it?
Resultant vectors sine 90.
Right. That is just a ratio, trigonometric ratio. What is the vertical component? How do you get the vertical component? You have to multiply the vector with it, right? That will be r sine 90. Do I have to repeat like the previous day's class again? Please let me know. Did you not understand? And you say that, okay, you understand everything the previous day, but in the space of 22 hours, you are uh, like, you are not even getting single thing. What went
I'm
wrong?
just I understand it. I just don't know how to put together.
All right, so what is the value for V sine 0?
V.
V sine 0 is V. If you
No,
tell
it's
me this after
zero.
reading trigonometry for 2 years, sine 0 is always 0. Okay. All right. U sine alpha equals to R. Okay. Sine 90 is 1. All right. So now,
1.
what one?
Sorry, just finite is 1.
All right. So R equals to U sine alpha. So what is the value for U? The value for U was 12. So 12 times sine 120. Please let me know what is the value for this.
10.39.
10.39. Okay. This is a very important math. Okay. So you should be able to do this, right? Other than that, it will be really difficult. Yes, there is a way where you can use that like formula of tan theta, but I do not prefer it because there is, say, if I consider this to a 90 degree, okay, 90 degree, then we work with like 1090 degree, right? But 1090 degree is not defined. It hasn't been defined. Okay. So then they write it something like 1 by 0 something something, which is wrong, completely wrong. Okay. So I prefer using the vertical and horizontal components. Okay. So now if I give a, like, just to test you about the knowledge of components, will you be able to do this now? Tell me,
Um,
what do you think?
I think so.
Okay, let's see. So are you done with this?
No.
You are not done with this? Okay, let me know when you finish this. Okay, honestly, I mean, did you check the notebook at all for even once?
Yes.
You checked it, okay. So that means you had some problem, right? So what is the problem?
Yes. Um, just 1 second.
Right.
Um, just I guess trying to put these ideas together.
Okay, first of all, tell me, are you done with this,
Yeah.
like taking notes of this?
Yeah.
Okay, okay. I mean, this is a very simple thing, okay. In case of horizontal component, what you have to do, okay. See, it equals to the vector or the vector's magnitude, whatever you want to call it, vector multiplied by cosine, and the angle will be angle between x-axis and the vector. Okay. And what is the vertical component? It will be equal to vector times sine, and again angle between x-axis and the vector. Okay, this doesn't change at all. They remain the same. Okay, there is no change in that. All right. So whenever you are given a system, say for instance, or a particular frame or a set of objects, and you have to work with it. So what you will do? Nothing. Okay. Say for instance, just a second. Okay. So you have say this force here. Okay. Then again a force here. Again a force here. Again a force here. Okay. You might be confused. Okay, what should I do? What should I do? So on, so on. Okay. But very easy. Say this is 7 newtons. Say this is 8 newtons. Say 10 newtons. And then say 12 newtons, okay, for instance. So now, say the angle is given. This is 30 degrees. And then this angle is also given, which is 20 degrees maybe. Okay. Now this angle is given, which is 10 degrees. And this angle might also be given, which is, say, for instance, 50 degrees. So what you have to do, see, for 7 Newton, just write down, okay, what we know, vector. I have to write on the vector, I have written on the vector. Now then what? Then again cos or cosine, okay. Then the angle between x-axis and the vector, which is 30 degrees, right? In the anti-clockwise direction, right?
Yes.
Understanding my point? Okay. Now tell me, what will be the horizontal component for 12 Newton? Step by step. First of all, what do we write?
12
Then
times cos
times what?
310.
310. That is the angle. And what will be the like trigonometric ratio?
Oh, cos.
Cosine, right? And in case of like vertical component, what will be the scenario?
Just replace the thing with sine.
Exactly. It's that easy. Nothing difficult in here. Okay, so the angle remains the same, even the vector remains the same. What changes in case of like vertical component from horizontal component is just trigonometric ratio. That is, it changes from cosine to sine. Nothing different here. All right.
All right.
Okay, so now let me know for 10 Newton. Let's see. For 10 Newton, let me know what is the horizontal component and what is the vertical component.
Now, our horizontal component would be 10 cos 200 and no 190,
Right. 10 cos 190. And in case
and
of
then
vertical component,
10 sine 190.
tell me, is it clear now? Or if you have any questions, okay, ask me. Is it clear?
It's clear. It's
Oh,
clear.
it has to be clear, okay? All right. And also the math of the board, it's also important, okay? All right. All right, so they haven't done with, say, the like formula of tan theta either, okay? So they have also used the component, okay? All right. So now let's do another math, which is a car is running at 40 kilometer per hour towards east. The driver of the car sees a truck running at 40 √3 kilometers per hour towards north. In which direction really the truck is running? And what is the actual velocity of the truck? Okay, let me give you another link. Okay, otherwise we might have to change the link in between the math. Okay, join fast. Okay.
Okay.